Welcome to A-Level and AP Physics. Today we will start a new series of videos for A2 Physics. In this series we will discuss all typical graphs, or simply we can say all possible graphs for A2 Physics, and we will discuss these graphs topic wise, so you can improve your conceptual understanding of each topic, and also you can have better understanding of this type of questions. Most of the time students they struggle with graph questions, simply they cannot understand how to answer them. And if you watch this series of videos carefully, I'm quite confident you will improve your conceptual understanding and you will be able to handle graph questions with confidence. It will also help you to improve your score in your exams, mean you can get better scores in your coming exam. So watch them carefully, and if you have any questions about these graphs, you can leave your questions in comments and I will answer as soon as possible. Let's study together, let's improve together. Question says electromagnetic radiation of wavelength lambda is incident on a metal surface. Electrons of maximum kinetic energy Emax are emitted. On figure 11.1, sketch the variation with 1 over lambda of Emax. So simply we need to sketch the graph between Emax and 1 over lambda. So for this question, now the question is that where to start. So you need to find the relationship between Emax, means kinetic energy maximum, and 1 over lambda. So for this purpose you have to use Einstein's photoelectric effect equation, and this equation is the fundamental equation for this whole chapter, so it's very important one. So you need to understand the energy of coming photon. This will be distributed between kinetic energy max. I can simply write on Emax. So this is the kinetic energy max of photoelectrons. So this one is the kinetic energy max of photoelectrons, mean the electrons emitted due to photoelectric effect, plus work function of metal. So this is work function of metal. It depends on metal. If the metal change, work function will change. Now simply we need to rearrange this one. So this is CAIE max, so don't get confused with this one. This is kinetic energy maximum. So if we rearrange this one, we can say CAIE max. In this case, this is equal to energy of photon, and energy of photon I'll be writing here. Energy of photon, we can say this is equal to H times F, or simply we can say this is equal to Hc over lambda. So we can write down here Hc over lambda minus we have work function of metal. We can further rearrange this one. We can say this is CAIE max. This is equal to Hc times 1 over lambda minus we have this is work function. Now simply we can compare this one with straight line equation. We can write on y, this is equal to mx plus c. From here we can see c is equal to negative work function, and gradient in this case is equal to Hc, and this is positive, so it means it's a straight line with positive gradient. So straight line with positive gradient, because this is 1 over lambda. So CAIE max and 1 over lambda, the graph between these two quantities, it has to be a straight line with negative y-intercept. So simply we have to draw the line here with y-intercept. So it has y-intercept, so you cannot draw from here. This one will be wrong. It means it has no y-intercept. It has y-intercept, so it should start from here somewhere. A number is not required, so you can start from anywhere, but you cannot start from the origin. Now if we extend this one, so this is our y-intercept, so you will get value of phi, the value of work function you will get from y-axis. So value of work function you will get from here. So this is value of work function. So this is how you need to sketch. So this is how you can sketch this one. Let me clean. So this is how you need to sketch for the answer of this question. Now if we go to the second part is asking us state an equation relating the gradient of the graph drawn on figure 11.1 to the Planck constant h. Gradient of the graph drawn on figure 11.1 to the Planck constant h means how gradient and Planck constant, they are linked together, relating these two, gradient and Planck's constant. So gradient we have already discussed that gradient is equal to h times c. Gradient is equal to h times c. Explain any symbols you use. So in this case, the symbol we have used this symbol. So this is the symbol we have used. So for the answer of this question, simply you will write down gradient. You will say gradient first of all, because you have to write down state and equation. So you have to write down this is equal to hc. Then you will say c is speed of light. So these 2 points you have to write down. You will say c speed of light, because this is the symbol we are using other than stated symbols in the question. So this is speed of light. So simply you need to write down this is speed of light. So if you write down this one, you will get 1 mark for here for this part, and you will get 2 marks for this part. I hope this one is clear to you. Part C says the metal surface in B becomes oxidized. Photoelectric emission is still observed, but the work function energy is increased. On figure 10.1, draw a line to show the variation with 1 over lambda of Emax for the oxidized surface. If you look at figure 10.1, we have Emax on y-axis and we have 1 over lambda on x-axis. So this graph will be very similar to the previous one. So first of all, we can write down Einstein's photoelectric effect equation. Means Emax, this is equal to energy of incident photon minus work function. We can little bit rearrange this. We can say Emax, this is equal to hc times 1 over lambda minus we have work function. And now we can compare this one with straight line equation. Y is equal to mx plus c. So in this case we have the gradient. So this is the gradient and this is positive. And y-intercept, this is equal to minus 5. So the graph has to be a straight line. But the question is that it is given to us that work function has been increased in this case. So work function, this is equal to negative 5. If this one has increased, it means that the c has to be greater. C has to be greater. So simply you need to understand this point. And gradient is the same, because still gradient is equal to hc. H is constant, c is constant. So these two lines, they must have the same gradient. In order to sketch this one, first of all, we can extend this line. So we can extend this line. We can simply extend this one. So this line we can extend. Now we need to draw a line that y-intercept is greater. So we have 2 options. You can draw the line here, but if you draw the line here, you can compare these 2 work functions. So we can make it little bit parallel. So these 2 lines have to be parallel. Now if I extend this line, for example, from here, you will see the previous lines. We can say this is line, let's say this is line 2 and this is line 1. So in this case you can see phi 1, this one is greater than phi 2, mean the c1, we can also say c1 is greater than c2. It means this is not right line, so this is not possible. So we can draw below this one. So you can check this one just for your better understanding. I want you to check this. So if I draw the line under this one, let me clean this part and draw a line under this. So this one I can draw a third line here. You can see this third line, its y-intercept is greater. So it means that we have to draw the line below the given line. So line has to be below this one, because in this case, if I say this is third line, this one is third line. So you will see the work function of third one, this is greater than work function of the first one. So this is the right one and this is incorrect. So simply you need to draw a line below the previous given line, and it has to be parallel and it has to be below. So this is how you can draw. So this is what you need to draw for the answer of this question. Rest of the things you need to understand why we draw a line like this. So this line you have to draw and it has to be under the previous line. Part B says photons having wavelength lambda are incident on a metal surface. The maximum wavelength for which there is emission of electrons is lambda naught. For photons of wavelength lambda naught by 2, the maximum kinetic energy of emitted electrons is E max. Maximum kinetic energy of electrons is E max when wavelength of incident photon is equal to this. On figure 5.2, sketch the variation with wavelength lambda of the maximum kinetic energy for values of wavelength between lambda is equal to lambda naught by 3 and lambda is equal to lambda naught, mean between these points, between this point and this point. For this question we have E max on y-axis, so this is E max. Again, kinetic energy maximum we have on y-axis, but on x-axis we have lambda instead of 1 over lambda. So the shape of the graph in this case, it will not be a straight line. So we can start again with photoelectric effect equation. We can write down E max. This is equal to Hc over lambda. This is wavelength of incident photon minus we have work function. But we need to understand work function. This is equal to Hc over lambda naught, and lambda naught actually this is the threshold wavelength, so we call this is threshold wavelength. So we can write down this is threshold wavelength. So this is maximum value of wavelength. If we increase more wavelength than that, there will be no emission of electrons, so we call this is threshold wavelength. Now simply we can write down in this case E max, this is equal to Hc over lambda. First of all, we can start when lambda is equal to lambda naught. So we can write down here lambda is equal to lambda naught minus work function we have. This is also Hc over lambda naught. So in this case, E max will be equal to 0. So this is one thing we can write down. E max in this case will be equal to 0. So this is one point we can write down. So E max has to be equal to 0. Now in the question it is given to us when lambda is equal to lambda naught by 2, kinetic energy, maximum kinetic energy of emitted electrons, this is equal to E max. So we can rewrite here. So I'll be writing here. So we have E max. So this is the second case, E max. So this one is the first case when lambda is equal to lambda naught. We can say this one is first case. Now we are looking at the second one. E max, we can say this is equal to Hc over lambda. So we have lambda. Now we need to replace this lambda with lambda naught by 2. So we can write on this is lambda naught by 2 minus we have this Hc over lambda. Now if we rearrange, we can say this is 2 Hc over lambda naught minus we have this Hc over lambda naught. So we will get here this is equal to Hc over lambda naught, and this is given to us, this is equal to E max. So this is equal to E max. So this is the second one. So when lambda is equal to lambda naught by 2 means then the wavelength of coming photon is equal to lambda naught by 2 kinetic energy, maximum kinetic energy of emitted photoelectron, this is equal to E max. So this is the second point. Now we need to understand when lambda is equal to lambda naught by 3. this one. Now simply again we can replace this lambda with lambda naught by 3. So we can use different color. So we can say in this case Emax, this is equal to HC. Lambda we need to replace with lambda naught by 3. So this is lambda naught by 3 minus we have HC over lambda naught. Now if we rearrange this one, we can write down this is HC over lambda naught, and we have 3 here minus this is HC over lambda naught. So we will get here in this case this is equal to 2HC over lambda naught. But we need to understand that Emax is equal to HC over lambda naught. So it means this is equal to Emax. So simply we can say here we have 2 times of Emax. So this one you can also say this is Emax 3, this one you can say Emax 1, and this one we can say this is Emax 2. And Emax 2 is equal to Emax. So this is Emax, this is equal to HC over lambda naught. Emax. This is given in the question. This one is already given in the question. When wavelength is equal to this one, Emax is equal to this. So this is equal to 2 Emax. So from here it is 2 Emax here, this point. So we can mark this point. And now we need to connect this point by a curve. So we can connect these points. So it will be connect points like this. So we can draw this one a bit better. We can draw this one a bit better. So simply you need to connect these points now. So we can, so this one looks better. So this is how you need to sketch the curve. So let me show you the better one. Better one you can sketch like this. Yes. So this is how you need to sketch. This question is a beautiful question. You need to understand if the graph between Emax and lambda, the shape of the graph has to be like this. And hyperbola, so shape has to be like this. And it has to be a curve. And when lambda is equal to lambda naught, it has to be 0. Emax has to be 0. So this point you have to keep in your mind. I hope this one is clear to you. If you have any questions about this one, leave your questions in comments. But this is a beautiful question. Practice by yourself more than one times, and you will be very confident about quantum physics graphs. Question 10 part A says a metal surface is illuminated with light of a single wavelength lambda. On figure 10.1, sketch the variation with lambda of the maximum kinetic energy Emax of the electrons emitted from the surface. On your graph, mark with the symbol lambda naught the threshold wavelength. So if you look at this figure, on y-axis we have Emax, and on x-axis we have lambda wavelength. And the same type of graph we have just sketched in the previous question. It means shape of the graph has to be the same. So again we can start with Einstein's photoelectric effect equation. Most of the graphs you will see are just based on Einstein's photoelectric effect equation. So again we can start with Emax. So the Emax, this is equal to HC over lambda, this is wavelength of incident photon, minus work function SC over lambda naught. From here we can take HC common. So we have here 1 over lambda minus we have 1 over lambda naught. So first of all, in this case we can look at first case when lambda is equal to lambda naught. So in this case we will have HC and 1 over lambda naught. So we will have here 1 over lambda naught minus 1 over lambda naught. So this one will be equal to 0. It means Emax will be equal to 0. So we can simply mark here any point somewhere here we can mark, or you can mark here anywhere, it doesn't matter. So let's say this is value of lambda, that is equal to lambda naught. So Emax at this point has to be 0. Now we can look at the second case. We can say this is over case 1. Second case we can say we have Emax that is equal to HC, and this is 1 over lambda minus 1 over lambda naught. Now we can consider the extreme case when lambda is equal to 0. When lambda is equal to 0. If lambda is equal to 0, so we are assuming lambda is equal to 0, so Emax in this case, you will see this will be equal to HC times 1 over 0, means infinite, minus 1 over lambda naught. So what we will get in this case, we will get this will be infinite, mean Emax will be infinite. So Emax will be equal to infinite. So this is extreme case. Physically this is not possible, but for the sake of understanding of this question, mathematically we can assume when lambda is equal to 0, it means it will never reach maximum value until infinity. So there will be along y-axis, there will be asymptote along y-axis, and the graph will intersect x-axis at this point. So simply we can draw the curve. So it has to be a curve and it has to cross this one. So it has to cross somewhere here. So this is how you need to sketch. So I hope this one is clear to you. Similar shape as we have done in the last part. So we have looked at two cases. One case when lambda is equal to lambda naught, so it has to be Emax has to be 0. The second case, if lambda is 0, but physically that is not possible, but theoretically we can assume. So Emax has to be infinity. There will be asymptote along y-axis. So this will be the shape of the graph, hyperbola. These two quantities, they are inversely proportional. So when lambda is decreasing, Emax is increasing. Part B says a neutron is moving in a straight line with momentum p. The de Broglie wavelength associated with this neutron is lambda. On figure 10.2, sketch the variation with momentum p of the de Broglie wavelength. Mean how de Broglie wavelength is changing with momentum. For this question, we have lambda on y-axis and we have momentum of neutron on x-axis. According to de Broglie wavelength lambda, this is equal to h over p, and this quantity is constant. So it simply means that when momentum increase, wavelength of neutron decreases, and vice versa is also true. So simply we can say in this case lambda times p, this is equal to constant, Planck's constant, and this is a constant quantity. So the relationship between these two quantities is inverse relationship, or simply we can say they are inversely proportional. So the shape of the graph has to be rectangular hyperbola, inversely proportional. So simply this is how you can sketch the graph. The shape of the graph has to be somewhat like this. So this is how you can sketch the graph. Let me show you the better shape of the graph. So if you draw in a better way, in a proper way, the shape of the graph will be like this. And that's all for today's lesson. And in the next lesson, we will talk about one new topic. May we discuss about nuclear physics and AC in the next video.